Good afternoon, guys. So hopefully you're enjoying your day off. So let's go through your review. So this is worksheet number 14 for chapter 4. And then the first part says, can the side lengths form a triangle? And then explain. So for number 1, we have, we want to see that any two side lengths add together to be greater than the third. Well, 3 plus 1 would be greater than 2. And 3 plus 2 would be greater than 1. So what we have to check is if 1 plus 2 is greater than 3. And we see that that's 3 box 3, where it's equal. So no, sorry about that. No, will not form a triangle. Okay, so our second one, we have again 6, 10, and 15. And we see that 15 plus 6 is greater than 10, and 15 plus 10 is greater than 6. So what we're interested in is if 6 plus 10 is going to be greater than 15, and you see that 16 is in fact greater than 15. So yes, it will form a triangle. And then we have 13, and we see that 30 plus 16 is greater than 12, and 30 plus 12 is greater than 16, but is 12 plus 16 going to be greater than 30? And that's going to give us a 28, which is less than 30, so no triangle will be formed. Down here, we have another set. I'm going to change my color so they don't bleed together. And again, we see that 13 plus 8 is greater than 7, and 13 plus 7 is greater than 8, but is 7 plus 8 going to be greater than 13? And we see that 7 plus 8 is 15, which is indeed greater than 13. So yes, it does form a triangle. And then over here, we have 16, 9, and 4. 16 plus 4 is going to be greater than 9. And 16 plus 9 is going to be greater than 4. But is 4 plus 9 going to be greater than 16? And we said that's 13, which is not greater than 16. It's less than 16. So we have no triangle being formed. And then our last one is going to be is if 5 plus 5 is going to be greater than 10. And we see that that's 10 equals 10. So no triangle formed. So remember, we're using that theorem we learned that any two sides of a triangle has to add up to be greater than the third side. If it's not greater than, there's no triangle formed. So on to the next one. Name the smallest and largest angles. So remember that the largest angle is opposite of the largest side. So our largest side is 18. So our largest angle is going to be angle B. Our smallest angle is going to be across from our smallest side, which is that side length of 5. And that's going to be angle C. The same question is being asked in 8 and 9. So we have our largest angle, smallest angle. Our largest angle is across from our largest side. Our largest side is 10. So our biggest angle, our largest angle, is going to be, and on mine that looks like a Q. So I'm going to put the measure, or just going to put angle Q. It could be an O. It just looks like a Q on my page. And then the smallest angle is across from the smallest side. That smallest side is 6. So the smallest angle would be angle R. And last but not least for this group, our largest angle is across from that largest side. Our largest side is 4. So that means that angle F has to be our largest angle, and our smallest angle is across from our smallest side, which is 2, so that would be angle H. The next group is doing the opposite of what we just did. Name the longest and shortest sides of the triangle, and so the longest side of the triangle is across from the longest or the biggest angle, and the shortest side of the triangle is across from the smallest angle. So we're going to go longest side, and then shortest side. So our longest side is across from that biggest angle, which is 70. So that's going to be that TS. Remember, this is a segment, so we put a line over it. Our shortest side is going to be across from our smallest angle, which is at 50 degrees. So that's going to be RT. Here we have to do a little bit to solve for our angle that was missing, angle A. So I did 180 minus the two angles that we have, so minus 71 plus 42. When we complete this, we get 67 degrees. So we see that really doesn't make any difference because the largest angle, so the longest side, can be opposite of that largest angle, which is AB. And then the shortest side is going to be across from that smallest angle, which will be AC. And last but not least in this group, again, we're missing angle J. We see that there's a 90-degree angle in here, so the other two angles have to add up to 90 degrees because they're complementary. So we just take 90 minus 35, which will give me 55 degrees. Again, that math was not necessary because 90 degrees is bigger than 55 degrees and 35 is bigger than 55 degrees. So we know that our longest side is opposite our biggest angle, so that's JH. And our shortest side is across from our smallest angle, which is KJ. The next group down here is named the angles from largest to smallest. So largest angle is the angle across from our biggest side. So the measure of angle M. And then remember, I make this super pronounced so you guys can tell the difference. So that's going to be is greater than. My next largest, or the one that's the next smallest compared to 14, would be the 10. And so the angle directly across from that is the measure of angle K, which is greater than the measure of angle, and then my smallest angle would be the one across from my smallest side, which is 8, which is angle L. For number 14, it's the same directions, and we see that our largest angle is the one across from our largest side, so that's 20. So the measure of angle Y is greater than the measure of angle, and we see that 15 is the next biggest. The side that's opposite of that, or the angle that's opposite of that side, is X, which is greater than our smallest side is that 7, which directly across from it is angle W. And then our last one of this category is our biggest side is that 40. So the measure of angle D is going to be greater than the measure of angle. My next biggest is that 38. The angle opposite of that is angle E, which is greater than the measure of angle. My smallest side is that 29. The angle opposite of that is angle F. So name the sides from longest to shortest. So again, this is the opposite of what we just did. So my longest side is going to be the side that is opposite of my biggest angle. My biggest angle here is 80. The side opposite of it is AC. So normally when I name segments, I put a line over it, but now we're talking about distances. So the distance of AC doesn't need a line over it, because when we talk about distance, we don't put a line, is greater than the distance of, and then my next one is at 60 degrees, so it's going to be BC, which is greater than the distance of AB. Over here, I'm going to solve for this angle, but we know that this is a 90-degree angle, so the other two have to be complementary, so it's going to be 90 minus 30, which will give me 60 degrees. And we see that my biggest side is going to be EF. So the distance of EF is greater than the distance of ED, which is greater than the distance of FD. And last but not least, I once again am solving for this. So I have 180 minus 120 minus 35, which gives me 25 degrees. So we see that the longest side is going to be that HG, which is greater than JG, because that's my next biggest angle. And then my smallest angle is at 25, so that's going to be HJ. So use the side lengths to classify a triangle as acute, obtuse, or right. So remember, this is going to be that C squared box A squared plus B squared, where C is our biggest side. So our C here we see is 14. So we have 14 squared box 6 squared plus 11 squared. 14 squared is 196 box 36 plus 121. 196 box, we're going to add those two together and we get 157. We see that 196 is greater than 157, and so if C squared is greater, we know that is obtuse. Here, our biggest side is 16, so our c squared is going to be 16 squared, box. Our two smaller sides adds together and squared. So 16 squared is 256, box. 225 plus 49. Here we have 256, box. We're going to add that side together, and we're going to get 274. We see that a squared plus b squared is greater than c squared. So our c squared is smaller, so we know it's acute. And then last but not least, we have our biggest side here, which is 82 squared, box. 18 squared plus 80 squared. 82 squared is 6724, box. 18 squared is 324 plus 80 squared is 6,400. So we get 6,724. And then we add up our right-hand side, and that also gives us 6,724. We see that these are equal, which means that it's right. On your test tomorrow, you have to make sure you show all the steps, or at least the first and this one. Our next group is that centroid with median problems. So remember, this is when we have to label our triangles. So here our statement is we have MK, and we want to find KN and NMN. So I begin every one of these problems the same way. KM equals KN plus NM. So remember, this is that segment addition postulate. The whole segment is equal to the sum of its parts. And then we have our distances here. I'm going to fill out the triangle. So the part from the vertex to the centroid is always going to be 2x. And the part from the centroid to the side that it is bisecting is going to be x. So I put in a 6 for my distance of km because it's given in the problem. And then I substitute in what I know here. So I have 2x plus x. I have 6 equals 3x. Divide by 3. X equals 2. So now that I have that, if I want to find the value of Kn, it's the same as 2 times x. We know the value of x is 2, so that's 2 times 2, which is 4. We also want to find the value of Nm, which is equal to x, which is 2. The next problem is a similar setup. We see once again we have the total value of Km. Km equals the sum of its parts, Kn plus Nm. Once again, we know the part from the vertex to the centroid is going to be that 2x, and the part from the centroid to the side that is bisecting is x. We know the total length of Km is 39, which is 2x plus x. Combine like terms, 39 equals 3x. X equals 13. So now that we have that, we have Kn equals 2x, which is 2 times 13, which equals 26. We also have Nm, which equals just x, which is 13. And the last one of this style, we have Km, our total segment, equals the length of its parts, Kn plus Nm. We see that the part from the vertex to the centroid is 2x. The part from the centroid to the side that it bisects is x. So we substitute in what we know. We have 60 equals 2x plus x. We have 60 equals 3x. Divide by 3. X equals 20. So now that we have this, we know that Kn equals 2 times x, which is 2 times 20, which is 40. And we have Nm equals just x, which is 20. Name the sides from longest to shortest. We just did this on the other side, but we'll continue on here. And we see that our longest side is the side opposite of our biggest angle, which is that 75. So that's going to be that OM, which is greater than, my next is that 74. So that's LM, which is greater than my smallest side, which is LO. We're going to apply that same principle over here. So we see that my biggest side, or my biggest angle, is that 81. What's the opposite of that? Is QP, which is greater than my next side, which is 50. So the side opposite of that 50-degree angle is PM, which is greater than my 49 degrees angle side opposite of it, which is MQ. And last but not least, we see that my largest angle here is 75 degrees, so the side opposite is MN. I know that N's running off the page, which is greater than the side opposite of my next largest angle, which is PN, which is greater than the side opposite of my smallest angle, which is PM. On the next one, we have to use the good old Pythagorean Theorem. So, using the fact that we know a squared plus b squared equals c squared, we're going to solve for the missing side lengths. Remember, c is always going to be your biggest side. And so that biggest side is my hypotenuse, which is what across my right angle. So we see that 26 squared equals 10 squared plus b squared. 26 squared is 676 equals 100 plus b squared. Isolate my variables, so we're going to subtract over 100. We get 576 equals b squared. We want to get b by itself. We have to perform that inverse operation, which is the square root. So we're going to square root both sides. Now that we have done that, we see that the square root of 576 is a perfect square, which gives me b equals 24. Again, we have a similar setup. It's again the Pythagorean theorem, but this time we're looking for a. So we have 15 squared equals a squared plus 12 squared. 15 squared is 225, which equals a squared plus 144. We want to get our a by itself, so we're going to subtract 144. When we do that, we end up with 81 equals a squared. Inverse operation. We are going to square root both sides to get our a by itself. This works out nicely. We see once again that a is going to be that perfect square, which is just going to be 9. And last but not least, now we are looking for the hypotenuse, so we're looking for that c. So we have c squared equals 5 squared plus 12 squared. C squared equals 25 plus 144. C squared equals 169. We want to get c by itself, so we do the inverse operation, square root both sides. C equals 13. Our last group on the bottom of this page is the distance formula. I'm going to write that off to the side. So if you don't remember, make sure you have this down. So we see that AB equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Remember, we go through and we label all of our points. So I have x1, y1, x2, y2. Okay, now that we have that, we have the distance from P to Q equals the square root of, so x2 is 3 minus negative 2 quantity squared plus 2 minus 1 squared. Inside here we have 3 minus negative 2, which turns that into a plus. So 3 plus 2 is 5 squared plus 2 minus 1, which is 1 squared. We end up with the square root of 25 plus 1 is 26. If you remember this from our review yesterday, this was one of the problems. And so we have the distance PQ is the square root of 26. If we were going to put it to the nearest tenth, that's going to be approximately 5.1. Our next one, I'm going to label again x1, y1, x2, y2. Okay, now that I have this, I have the distance PQ equals the square root of x2, which is 3, minus negative 1 quantity squared, plus 0 minus 2, quantity squared. Once again, we have 2, a minus, a negative, which turns it to a positive. So we have 3 plus 1, which is 4 squared, plus negative 2 squared, or so that's the same thing as negative 2 squared, which we know negative 2 squared is 4. So that gives me 16 plus 4, which is 16 plus 4 is 20. We can do a factor tree here. We see that that is 4 and 5. This goes to be 2 and 2. They have a buddy. They get to escape. I'm going to change colors so you can see that I'm writing my solution. I'm also going to draw a wall. So my solution here, we see the distance from PQ equals, and then we see that 2 escapes. Doesn't escape, stays locked under that reticle. So 2 square root of 5. And then the last one in this category, for this page at least, we're going to label these x1, y1, x2, y2. We have the distance PQ equals the square root of x2, which is 3 minus 0 squared, plus y2, which is negative 1 minus 3 squared. We end up with the square root of 3 squared plus negative 1 minus 3 is negative 4. Negative 4 squared, which gives me the square root of 9 plus 16, which is the square root of 25. We know that the square root of 25 is, it's 5. Okay, so we lucked out on this next worksheet because apparently we didn't finish typing number 1, so you can't solve it because there's not a third side. So classify triangles by the given side lengths as acute, right, or obtuse. So again, we use our C value, which is our largest one, which would be 15. So 15 squared, box 9 squared plus 12 squared. 15 squared is 225. Box 81 plus 144. We bring down the 225. We bring down our box. 81 plus 144 is going to give me 225. So we see that these are equal. Therefore, it's right. So when the two values are equal, a squared plus b squared equals c squared, it's right because that's the Pythagorean theorem. Our next one, we see that we have our c value as 14. So we have 14 squared, box 9 squared plus 12 squared. This is convenient because we already did this portion on this spot right here. So 14 squared is 196, box, and then that's going to be 225. We see that that is going to be bigger, so c squared is less than a squared plus b squared, which tells us that's going to be acute. And then our last one is going to be our c is our largest value, which is 9 squared, box 3 squared plus 7 squared. 9 squared is 81, which is greater than, which is box 9 plus 49, 81, box, and we see that that's going to be 58. So I kind of slipped already and told you 81 is greater than 58, which means that it is obtuse. Once again, we have the distance formula, so this is good practice. So we have AB equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to label my points, x1, y1, x2, y2. So the distance AB equals the square root of x2, which is 3, minus negative 3, quantity squared, plus 11 minus 3 squared. So we have a minus and negative, which makes it positive. So we end up with 6 squared plus 11 minus 3 is 8 squared, which gives me the square root of 36 plus 64. If you add those together, you see this is the square root of 100. Square root of 100 is, or 100 is a perfect square, so when we square root it, we get 10. And then over here, we want to find the distance of CD. x1, y1, x2, y2. So I end up with the square root of negative 6 minus 0 squared plus 2 minus negative 3 squared. So I get the square root of 36 plus, so this became 6. 6 squared is 36. 2 minus negative 3 is 5. 5 squared is 25. So when we add those two together, we get the square root of 61. We see we can go no further. We can just box that in. I'm going to change color since I bled into the other box. So we'll draw a little line to separate it. We see x1, y1, x2, y2, EF equals the square root of negative 1 minus 2 squared plus negative 2 minus 2, negative 2 minus negative 2. Squared, which gives me negative 1 minus 2 is negative 3 squared is negative 3 squared. Plus, over here we have negative 2 minus negative 2, which gives us 0 squared. This becomes the square root of 9. 9 is a perfect square, so our distance is 3. Once again, we have the Pythagorean Theorem. So we have c squared equals a squared plus b squared. C squared equals 12 squared plus 12 squared. C squared equals 144 plus 144. C squared equals 288. Okay, for space, I'm going to draw the rest of my work up here. So we have the square root of 288. I have to figure out if that can factor into anything I can simplify this radical with. So we see that 4 goes into this. When we put 4 in, we see we arrive at 4 times 72. 4 breaks down to 2 and 2. 72 breaks down to 9 and 8. 9 breaks down to 3 and 3. 8 goes to 2 and 4. 4 goes to 2 and 2. So what has buddies? That's my 2's, my 3's, my 2's. So I take each of the numbers I circled and I multiply them together. So 2 times 3 is 6. 6 times 2 is 12. I end up with 12. Radical, what doesn't have a buddy? What doesn't have a buddy is this lonely guy right here. And so that goes to 12 square root of 2. On number 9, I didn't give any numbers there, but once again, I did choose to fill it in myself. So this one we will work out, and I put a 12 right here. So we have 12 squared equals a squared plus 8 squared. Let's erase that. That's just messy. Okay. So a squared plus 8 squared, 144 equals a squared plus 64. Subtract 64 over. 144 minus 64 is going to give us an 80. So 80 equals a squared. Square root both sides. I'm going to bring my work up here once again to ensure we have enough room. So I have a equals the square root of 80. This goes into being 8 and 10. 2 and 4. That goes to 2 and 2. This goes to 2 and 10, or 2 and 5. So things that have buddies are these 2's and these 2's. So 2 times 2 is 4. Square root of 5 is my value of a. And then the last one in this category is now solving for b. So I'm actually going to start working up higher this time. So my c value is that 24 because it's my hypotenuse. C squared equals a squared plus b squared. 24 is 576 equals 121 plus b squared. Isolate the variable, so we want to subtract our 121. I end up with 455 equals b squared. Square root both sides. I want to now figure out what we can break 455 down to 455. So I take out a 5 because it ends in a 5, tells me that 5 is a factor. 5 is a factor, then we see that 91 is also 1. The factors of 91 are 7 and 13. All of these are prime numbers. None of them have a buddy, so b equals the square root of 455. Over here, we are solving for the missing variable. This is something you guys struggled with during our review game yesterday. Remember, the sum of the interior of a triangle is 180, and it has to equal all the angle measures, so that's 40 plus 65 plus x plus 83. We add together our constant terms, which is 40 plus 65, which is 105 plus 83, gives me 188. So 180 equals 188 plus x. We want to get x by itself because that's what we're solving for. So we're going to subtract 188. X equals -8. Over here, we want to find our exterior angle x. So the value of our exterior angle x is the same as the two interior non-adjacent angles. So those angles would be this angle here and this angle here. But we don't have that second angle, so we have to solve for it. Well, these marks here tell us that these are an isosceles triangle, which means that my base angles are congruent. So that means that these each have a value of y, or any variable you chose. So we know that 2y plus 50 equals 180. I subtract over 50. I get 2y equals 130. I divide by 2. Y equals 65 degrees. So I see here that this y equals 65. So to find the value of x equals the two interior non-adjacent angles, which would be that 50 plus 65. So x equals 115 degrees. Our last example. So once again, we see we have two congruent sides, and the angles opposite of congruent sides are congruent, which means that 66 equals 3x. We're solving for x. We divide by 3. We get 22 equals x. So again, remember, if you have congruent angles, the sides across from them are congruent. If you have congruent sides, the angles across from them are congruent. Good luck on your test tomorrow. Please let me know if you have any questions.